Everyone is ready. So we start with preparation of isoquinoline. So there are total 4 steps here. First, I am going to write down structure of isoquinoline. I hope everyone know this structure. So this is the structure of isoquinoline and we going to prepare this compound. So here I start with step number 1. Step number 1. In step number 1, our starting material is benzaldehyde. So here there is a condensation of benzaldehyde with nitromethane. To form omega nitrostyrene. Student, let's study this how this reaction going to take place. So student, this is the benzaldehyde plus nitromethane means CH3NO2. This reaction is carried out in presence of base. So student, this reaction is condensation reaction, and in condensation reaction there will always removal of small molecule like water. So here also there is a removal of water. So oxygen is removed from benzaldehyde and 2 hydrogens are removed from carbon atom. So what will be the structure when this type of elimination takes place? We get this type of structure. CH double bond CHNO2. Right? Now here the compound form is called omega nitrostyrene. Now as you can see here, this is the alpha beta omega. So student, this is the omega nitrostyrene formation. This is our step number 1. Step number 2. In step number 2, there is a reduction of nitrostyrene. Reduction of nitrostyrene. So I write here nitrostyrene. Now I can write this compound like this. Now this undergoes reduction. Reduction in presence of reducing agent lithium aluminum hydride, and there is a reduction takes place. So what happened after reduction? After reduction, double bond converted into single bond and NO2 group converted into NH2. So see here, this C double bond C converted into C single bond C, and this NO2 group reduced to NH2. Now what is the name of this compound? Name of this compound is beta phenyl ethyl amine. So in step number 2, there is a formation of beta phenyl ethyl amine. Now students, step number 3. Step number 3 is about acetylation of beta phenyl ethyl amine. So there is a acetylation takes place. This acetylation is followed by dehydration. So this is the step number 3. Step number 3 is very simple. Acetylation of beta phenyl ethyl amine followed by dehydration. Now, first I draw structure of beta phenyl ethyl amine. Then there is acetylation takes place. Acetylation can be carried out in presence of two reagents. First reagent is acetyl chloride, or another reagent is acetic anhydride. So what happened in this reaction? In this reaction, this Cl and one of the hydrogen from NH2 is removed as HCl. So here there is a removal of HCl. Right? So first of all, I should write this NH2 here. Then I have to remove one hydrogen from this NH2, and there is an attachment of this CH3 C double bond O group. So there is an attachment of C double bond O CH3 group. Right? So this is the acetylation. This is not dehydration. Dehydration means removal of water molecule. So actually this step number 3 is again consist of two steps. In that, first step is acetylation and second step is dehydration. So I'm going to show here dehydration step. Dehydration means there is a removal of water molecule. But to remove this water molecule, we always require some dehydrating agent. So for this, we have to add PCl5 as a dehydrating agent, or phosphorus oxide P4H10. So this PCl5 and P4H10 acts as a dehydrating agent. Dehydrating agent means agent which remove water molecule. So how water molecule is going to remove? To remove water molecule, this bond should be shift here on this carbon atom. Then there is one hydrogen on benzene ring. So this hydrogen, this O and this H. As you can see, two hydrogen and one oxygen. This remove as water molecule, and after this we get product with removal of water molecule. So this is the product formed with removal of water molecule. Now step number 4. Step number 4 is dehydrogenation of 3,4 dihydro isoquinoline by palladium in presence of copper at 100 degrees Celsius to give 1-methyl isoquinoline. So student, this step means this is the last step, and this last step is very simple. We just remove hydrogen atoms, and due to removal of hydrogen atom, there is a formation of double bond takes place. As you can see here, there is a no double bond, but due to this dehydration or reduction, there is formation of double bond here, and we get our required product. So students, this is the synthesis of isoquinoline. Now, student, please go to your chat and tell me you understand these steps, or if you have doubt in any step, please let me know. Okay, so some students want me to repeat last step. Okay, so I'm going to repeat, but before that, I'm going to revise all these steps again. Okay, sir. Okay, students. So step number one, here, as you know, we're going to prepare isoquinoline. So isoquinoline, first step is condensation of benzaldehyde with nitromethane to form nitrostyrene. So this is benzaldehyde, this is nitromethane, two hydrogen from this CH3 and oxygen from this benzaldehyde remove as water molecule and we get product styrene. Then there is a reduction of nitrostyrene. After reduction, this double bond converted into single bond and NO2 group converted into NH2. Then acetylation of beta phenyl ethyl amine followed by dehydration. So as you know, there is a first of all acetylation takes place, and after acetylation there is a dehydration. But due to this dehydration, we get carbon nitrogen double bond. And last step is dehydrogenation. Dehydrogenation means removal of hydrogen atoms. So as you know, here two hydrogen atoms are there, and here also two hydrogen atoms are there. So one hydrogen from here and another hydrogen from another carbon atom remove. But due to this removal, here we get carbon-carbon double bond. Right? So this is very simple idea. So if hydrogen atoms attach in the reaction, then there is a double bond converted into single bond. Okay? And if you remove hydrogen atoms from that carbon-carbon single bond, we get carbon-carbon double bond. That is very simple step. Okay, so here we get one methyl isoquinoline. Actually, we here going to prepare quinoline, isoquinoline, but here we get methyl isoquinoline. So you in a few more steps, we also remove this methyl group. Means this methyl group first we have to convert into acidic group, and this acidic group again we have to remove by decarboxylation. But that steps are not in our syllabus. Okay, so actually our aim is to prepare one methyl isoquinoline. So in exam, if question is asked on this, how to prepare one methyl isoquinoline or how to prepare isoquinoline, you have to write down these steps only. Okay. So let's start with another part, or we can say next part, because here we already completed preparation of all the three heterocyclic compounds which are in our syllabus, and that are pyridine-N-oxide, quinoline, and isoquinoline. Now we start with reactions part, and here first we're going to see reaction of pyridine-N-oxide. So here we're going to study reaction of pyridine-N-oxide. Now for this, we going to study this reaction in very simple manner, very short manner. So first I draw here pyridine-N-oxide. This is pyridine-N-oxide, and we're going to study reactions like this. So here first reaction is halogenation. Halogenation means reaction in presence of SOCl2 or POCl3. So this is the halogenation reaction. But as you can see here, which halogen is present? Chlorine. That's why this is called chlorination. And what product we get here? Here we get two products. And product is 2-chloropyridine and 4-chloropyridine. Now student, as you can see here, okay, what should be your observation? Observation, as you can see here, this oxygen is removed in this reaction. मतलब नाइट्रोजन के साथ जो ऑक्सीजन एटम है वो यहाँ से रिमूव हो चुका है, एज यू कैन सी. ओके, गलती से आप रिएक्शन दिखाते वक्त ऑक्सीजन के साथ रिएक्शन दिखा सकते, बट इन दिस रिएक्शन ऑक्सीजन एटम इज रिमूव. ऑक्सीजन एटम के साथ आपको रिएक्शन नहीं दिखाना. यू शुड रिमूव दैट ऑक्सीजन and attach chlorine at position number 2 and position number 4, and that's why this reaction is called chlorination reaction, and the product we get is 2-chloropyridine and 4-chloropyridine. Now another bromine, another halogenation we going to see here is bromination. Bromination is carried out in presence of bromine in presence of oleum. Oleum means very concentrated sulfuric acid, and this reaction is carried out at 70 degrees Celsius temperature. The product we get here is this one. So what is the name of this product? This product name is very simple, 3-bromopyridine-N-oxide. Now in this, when you add zinc in presence of zinc dust, then zinc remove this oxygen as zinc oxide. Which oxygen? This oxygen and this zinc is removed as zinc oxide, and the product we get is pyridine with bromine. Means here product is 3-bromopyridine. Name of the product is 3-bromopyridine. Right? So here these two reactions are halogenation reactions. In halogenation reaction, first one is chlorination, where we get 2-chloropyridine and 4-chloropyridine. In bromination, first we get 3-bromopyridine-N-oxide. Then there is the addition of zinc. Zinc remove this oxygen from nitrogen as zinc oxide, and the product we get is 3-bromopyridine. Now next reaction. Next reaction is nitration reaction. Nitration is carried out in presence of concentrated nitric acid and concentrated sulfuric acid. What is the product form? This nitro group, because nitration reaction is nothing but addition of nitro group, and this nitro group attach at position number 4. So this is called 4-nitro. Name of the product 4-nitropyridine-N-oxide. Very simple. Name of the product is 4-nitropyridine-N-oxide. Then next reaction is amination reaction. In amination reaction, NaNH2 and liquid ammonia acts as a aminating agents. Amination means there is the attachment of NH2 group. So we get this compound. First one is called 2-amino-pyridine-N-oxide and second one is called 3-amino-pyridine-N-oxide. Now last reaction in this. Last reaction is addition of N-butyl lithium. Bu means butyl group, N-butyl group. There is an attachment of N-butyl group. What will be the product? Now in this case, lithium attached with position number 2 with removal of N-butyl H means it is removal of N-butane. Means here N-butane is going to remove and lithium attached at position number 2. Then there is an addition of carbon dioxide followed by hydrolysis. So when lithium compound is there and when this treated with carbon dioxide followed by hydrolysis, then that lithium group completely converted into COOH group. That lithium group is converted into COOH group. Now what is the name of this compound? Name of this compound is Pyridine-N-oxide 2-carboxylic acid. So students, here we completed the reactions of pyridine-N-oxide. So here we make a very short form or we take very shortcut. In shortcut manner, we completed all the reactions. As you can see, I will provide notes based on this. So don't worry about this. Okay, only thing you have to remember is in chlorination reaction, there is a removal of oxygen atoms. This is the important thing. Now in this case, as you can see, first reaction is chlorination, where we get 2-chloropyridine and 4-chloropyridine. In bromination, first we get 3-bromo-pyridine-N-oxide. Then there is an attachment of zinc. We get 3-bromopyridine with removal of zinc oxide. Then there is a nitration. In nitration, we get 4-nitropyridine-N-oxide. Then there is a amination where NH2 group is attached. We get 2-amino-pyridine-N-oxide and 3-amino-pyridine-N-oxide. Then there is an attachment of N-butyl lithium. Lithium group attached at carbon number 2. Then carbon dioxide and followed by hydrolysis, we get pyridine-N-oxide 2-carboxylic acid. So students, if you have any doubt, you can go to your chat